just want to remind you that now we have our session for AI dummies given by Nerds in order to provide you with some fundamentals and basic things and terminology that we can discuss. So keep our further discussions and collaborate effectively.
With uncertainty of data, the noisy data, because all data is presented in the physical form, and modern signal inputs and signal outputs for the hardware are not improved today to process a lot of data. The next problem is dynamic world. Dynamic world is the real-time processing and time continuation computation, which are defined from the hardware time processing too. And mapping can be defined as a clusterization of this problem to their applications. And the main applications in this work are factory automation, field and service robotics, military applications, medical care, character recognition, human identification using various biometric models by face or by fingerprints. If we are talking about fuzzy logic, what is the main and provided here? First of all, when we are talking about Boolean logic, which was defined firstly, we can give it's only the example questions. Is it hot temperature when we are discussing about some patient or about some water control? We can construct the computer systems only in two ways, as it was in for 25th century, and it can be yes or no. So we only have two options for this. When Zade introduced fuzzy logic in 1975, we can construct the theoretical approach was to give the probabilistic variables to all to the input of this computer system. So when we define is it hot temperature, we can define it as very hot, which are divided to 1, as warm, which is divided to 0.5, or very cold, which are defined to cold. On this slide, you can see the fuzzy controller design. It's only a simple way when we have two inputs. The first input is the deviation on the wheel track, and the second input is the speed in a particular moment. The fuzzy speed has, in Montana, has 25 base rules, and the output is the speed for forecasting problem. So here we forecast the speed in the next period of time. The picture below on the left shows our surfaces, and this problem was staged for the diesel train Del 002. And we can see that optimal speed here from 0 to 15, and optimal standard deviation from 0 to 6 millimeters. Thank you for your attention.
Just briefly, some questions from the audience, as we have time. So, do you have any questions? Or maybe you can briefly describe in a few words fuzzy logic, some keywords.
Fuzzy logic, different meanings, different applications, probabilistic variables, and nice computer and programming software. This work actually was made in MATLAB. So it's, I think, the best tool for fuzzy calculation.
Awesome. let's support our presenter and then continue. So, yeah.
Well, if we have more time, I would just a bit continue with what I have started before, but it doesn't depend.
Okay,
It
Nada,
depends.
please choose professor from a talk.
The intro to,
It was previous one from what session?
and then go to the.
USB stick.
It's
Yeah.
my USB stick. Yeah, word insert.
Okay, since we have, I think, like 10 minutes or so.
Not 10, but 7, I think.
7.
Not so, yeah.
Okay, 7 doesn't. That is too short. Then we go earlier, or?
I think it's possible. It makes sense to go early and eat, not in a hurry, and discuss some issues
Okay.
regarding sessions. So I would like to say thank you to everybody who participated, who actively participated and are expecting the same from Nano side, from Nano participants, and then we can have one more lecture and workshop for today. Okay, then I provide you with all of the details a bit later. Now it's all. Thank you. Namaste. Maria Kaidas, please. Do we have? Yeah. You can start and ask.
I need a pointer.
We can do it without pointing because it doesn't work properly.
Okay.
Oh, you can try, but
No problem. Maybe I
It's really
can just save it.
Nadia,
one
could you
slide
please,
to go forward.
help with switch slide, yeah?
Shall I show my presentation? Oh, yes. So here is it, my presentation. So hello, everyone, dear organizers and participants. My name is Maria, and today I'm going to show you the presentation, which I'm to show the point where natural sciences meet with IT. And this point is professional software. And I ask you to forward the presentation. Yeah, so artificial intelligence applied to chemistry became one of 10 top topics distinguished by EU PAC as the important topics for the development of the science. And all the time, every day, working in the pure field of natural sciences, we face with IT every day because we need to work with computer programs. Different program makes difference in, and programs transform our laboratories. They help us to design molecules, to analyze the data, and frequently it is so that without a computer program we cannot go forward. But today I will briefly show how the elucidation of the structure of one molecule is simply possible with just a set of computer programs. Please forward the presentation. So if we, for example, imagine that we have synthesized some molecule, and we have to know which structure is it. Of course, we know what we want, but we have to prove if we are right or not. So what can we do? First, we can do a mass analysis. Please forward the presentation once and twice backwards. One more time backwards. Thank you. So the first analysis, for example, if we have some molecule in mind and we did a mass spectra, we read the data with the chemical software here on the left is one example of many different programs for that. For example, Mass Hunter from Agilent Technologies. Gratefully to that software, we know the mass of the compound. Like the mass says nothing about the structure, but it gives us all atoms which are inside, which we see on the right, just a set of atoms. And now please, one time forward. Yeah, so then we do a next analysis, NMR spectra, and we use again the chemical software to read the spectra. And we have a clue about the structure of the molecule, more or less. And then, please, one forward. We do a third set of analyses, and we get a crystal structure of the molecule and its real organization in the space. How does it look and what is it? And such crystal is actually a confirmation of what we were about to synthesize. And then again, forward. Yes, and if we want to know how we can apply our substance, we use the fourth set of programs to make a classification and to predict where this molecule could be useful. We can, molecular docking is available for us to predict where is the substance in our body, for example, if it is inside. So here are on the left just some examples of professional software which we use every day. And the message of my presentation is that really our collaboration of IT and chemistry is very fruitful. And thank you for giving us the possibility to communicate. And please once more forward. Yeah, I thank for the attention.
I have a question about the ChemDraw program. I used only for drawing molecules. What else can we do?
Yes, actually you notice it because maybe your profession also deal with this program about the logo. Could I ask you please to go backwards in the presentation once? Okay, no matter. So yes, in the ChemDraw, you can visualize the molecule like no one 4 times forward. Yes. So this picture, which is blue, where the molecule is rotating, is ChemDraw. Actually, this is ChemDraw 3D. Yeah, that's why this logo is on the slide. Yeah, but actually, this molecular docking is done, of course, not with ChemDraw, with another program, but this logo was also suitable here. Thank you for the question. You noticed it.
So you helpful tools for chemists, biologists.
Yes.
Yeah. Thanks.
Yeah, thank you very much.
Please correct if I.
Can you find my slides? Yeah, this one, thanks. And I'll just a bit extend the previous report. And please turn to the next slide. And next slide, please. And as you can see that in case of computer-aided drug design, we need to know what does it mean. It's a small molecule, usually a small molecule that can interact with the drug target that's mostly a protein and a large molecule to cause any effect on the cell and tissue and organs. Please click one time, and as you can see that the drug should be like a right key to this lock that is a protein in the cell. Next to slide, next to clicks, as you can see, the drugs will consider small molecules and drug targets as large molecules. Next slide, please. The traditional drug discovery life cycle is too long because it takes about 5 to 7 years to develop it. And because, first of all, we can to synthesize or to modify or to do anything else with the right compound, and just after that we can take some preclinical and clinical trials before we get the right result or the wrong result, and so on. Next slide, please. And of course, it's too difficult to develop new families of medications if we choose just molecules and nothing else. What this thing, computer-aided drug design can ease this process of discovery of new drugs. Because we can use those computational approaches to discover and so on those biologically active molecules. Here you can see those 3 steps of the computer-aided drug design, because first of all we can use software for the virtual screening-like structure and beacon-based design, then optimize not only this molecule but its interaction with the target. It's called docking. And the last one, the optimization of this lead molecule, if we need some more compatibility and so on. Please, next slide. Here you can see that the most usable 2 approaches are target-based drug design strategy and ligand-based. The ligand-based is used if we know any molecule before with its structure, and then we just can construct something like this using the software. And if we know the structure of the target, of course, we can try to construct any molecule that is compatible to it or that can dock to it. Next slide, please. And here you can see the categories of software used for the computer-aided drug design. First of all, you can use different databases and draw tools, then the software for molecular modeling and homology modeling, then binding site prediction and docking software. The different apps for the ligand design and screening and quantitative structure and so on things. And then the last step, as you can see, is very important because it's associated with the medical effects of the drug, and it's means that administration, then toxicity and metabolization, and excretion of this drug. Yeah, the next slide, please.
Any questions? You said at the beginning of your talk about drugs as small molecules. Small molecules is just a class of drugs. What about peptides, antibodies? Can you use the same approach for that?
Yes, I thought that we'll ease our discussion just if we consider those drugs as small molecules. But of course, some medications are large molecules, like these mRNA vaccines. This one, Comirnaty and so on. They're really large, and their size is over this limit of 900 Dalton, of course. And of course, we can use some bioinformatics tools to construct such things. And as I can remember, this sequence of nucleotides was decoded using Ensemble or any other software.
Please.
Yeah, thank you, Iris, for the presentation. My question is, do you know about some software in which we can model docking or adaptation of proteins to the nanoparticles, or like a model low scale, like a particle and part of protein.
Yeah, I see. I think so. It was. Can you turn backward? Sorry, Nadia. Can you turn one slide back? As you can see, this dog, I think so, and Swiss dog are useful for this purpose. No, for Metsumo and so on, they are for binding sites, but dog and Swiss dog, they are for docking prediction.
How about nanoparticles?
About nanoparticles, basically, even those vaccines, Comirnaty and Moderna, are nanoparticles. So they were used to, I mean, the software was used to predict their binding.
Okay, thank you.
Yeah.
Then I'd like to thank you, and we're just finishing our session. So our next presenter, I invite Alina Nechyporenko, please, overcoming overfitting in image classification using data augmentation. Please, your turn. 5 minutes.
Hello everyone, my name is Alina Nechyporenko. I'm a PhD student. The topic of my presentation is overcoming overfitting image classification using data augmentation. First, I want to talk about the overfitting. It occurs when the gap between the training error and test error is too large. In simple words, overfitting is a condition when your models predict values for training data very accurately as compared to unseen data. It then becomes difficult for the model to generalize new examples that were not in training set. This graph shows the classification result on the training set, which eventually reached up to approximately 95%, the blue line. Below there is the classification result for the validation, the orange line. As you can see, the result for both sets began to diverge already around the 15th epoch, and the final difference for 80th epoch was a high approximately. Approximately 25%. We call this situation overfit. So let's move on to see how we can prevent overfitting. One of the best techniques for reducing overfitting is to increase the size of the training dataset. In real-world scenarios, gathering large amount of data is a tedious and time-consuming task. Hence, the collection of new data is not a viable option. In image augmentation, we do some manipulation in exciting images and generate new images from old. For example, we can just rotate the image and generate a new image from the old one shown in the picture. Here, picture 1 the original, picture 2 after rotating the original one by 90 degrees. We can apply various changes to the initial data. For example, for images we can use geometric transformation, as you can randomly flip, crop, rotate, or translate images. Color space transformation, change RGB color channels, intensify any color. Color filters, sharpen or blur an image. Random erasing, delete a part of the initial images. Mixing images, basically mix images with another. As we can see, using data augmentation, a lot of similar images can be generated. This helps in increase the size, the data set size, and thus reduce overfitting. Now we look at data generation, simple implementation with Keras. In Keras, this can be done via the image data generator class. This is a simple example of our common overfitting and image classification using data augmentation. That concludes my talk. I'd be Thank you very much for your attention.
Questions from the audience? Maybe you want to add something? Yeah, and do you know, actually, did you use some of the approach that you introduced already
Yes.
in your research?
Yes.
Which particular?
Yes, my data set is biomedical. It is not large. The data augmentation. I use that augmentation for the large the data set large.
So we have a lack of data. Yeah, it's clear for everybody. We need more data, and we can use such an approach in order to augment our data. And one of the really popular architectures, generative adversarial network, it can be used for data augmentation. Maybe somebody of you already work with this architecture and want to share his expertise, but not now, later. Thank you. Next. So I invite Victor. Victor? Okay. Then, this Ivan is on. Taking models for improving prediction.
Sorry about that. So,
Okay. Could you
Maybe you help me.
Madam, could you help us?
Okay, thank you. Dear colleagues, next slide, please. My name is, I am Ivan Izonin, Associate Professor at the Department of Artificial Intelligence of the Polytechnic National University. Today I try to explain you the stack ensemble approach for prediction and classification in artificial intelligence. Next slide, please. And next one, please. I am currently working as a high-speed computational lab of Lviv Polytechnic National University. Lab head is Professor Nechyporenko. Next slide, please. Dear colleagues, who are the nano nerds in this audience? During my presentation, thank you, I ask you to help me. Yesterday I come to Kharkiv. It was the second time here, and I found some apartment in booking. But when I come to Kharkiv, my phone was broken. I know the name of the street. I know that my apartment is near the McDonald's, and near my apartment is some Cafe Victoria. I am in the train station, and what I should do? I do not know the way. I don't know the way where to go. What I should do? Ask people. Yes. Next slide, please. I ask people. Question is some input information. My questions. People show here is black box for me because I don't know such as this man or woman, and answer of this man or woman is the output of our model. But I asked some people, it's a black box for me. I don't know, maybe the information provided by this man or woman is mistake, or he or she lies me, or something else. How I can increase my chances to find a way where I should go? Ask more people. It's one strategy. But it's another strategy. I can ask different questions for the same person. I know the name of the street. I know that my apartment is near McDonald's, and so on. We have two strategies. In machine learning, when we use two and more models to prediction or classification, we call it ensemble. There are different ways to build an ensemble model, and today I will try to explain the stacked approach. When we use two or more models that can work parallel, we called it a stacked model. Next slide, please. The theoretical argue of this approach you can find in Jury theorem and the principle of wisdom of the ground. Next slide, please. As I told, we have two different strategies to build the ensemble. The first one, when I have the same questions and ask the same data. When we translate it to machine learning, we have the same data sets, the same questions, and ask for different persons. Model 1, it's one person. Model 2, it's second person, and so on. Then we have some meta models that collect the output of each models, in our case for each person, and try to learn how to find out. For example, I ask 4 people. 3 of them tell me that I should go on the right side, and 1 tells that I should go to the left side. I have 3 persons that tell me one direction. Therefore, I choose this one. It's a majority voting in machine learning. It's principles used for classification. Next slide, please. The next one strategy, I can ask different questions for the one person. For example, I ask, where is the Malinovskoe street? I ask the one person. The second question, where is the McDonald's? And so on. It's also a good strategy to build the stacking model, and in some cases, it provides very good results. Next slide, please. The first example I show you when we use a first strategy. When we ask the same questions, but to different persons. We have different machine learning models. In our case, it's different persons, Adam Pust, random forest, and others. I ask the same questions, where is the Malinovskoe street, or provide one data sets for each images. And provides, I ask different persons. And our meta model collects these outputs and try to find the best way. As a result, you can see on the chart, it's coefficient of determination. This performance indicator should be higher. If it's higher, it's good. It's the smallest, it's bad. And proposed stacked model provides a best solution in a comparison with other single models that built it. Next slide, please. The next one's example is the second strategy. When we use different questions asked to one person. In this case, I use it's a neural network. It's a sum model in artificial intelligence, general regression neural network. It's only one network, and I provide to it different data. There are also different strategies to provide different data, but in this case, I use my algorithm. And as you can see, in this case, we have looking square error. This performance indicator should be smallest. And our
running out of time.
sentence.
Summarize briefly, and then we
Next slide, please. Stacking, it's some approach where when we can use diversity. And you can easy to try this approach using Orange software when you know something about data and something about machine learning. Thank you very much.
I think we will be able to discuss the benefits of ensemble approach later. So now I invite Victoria, please. Never mind. 5.
It won't help because I would like to ask Nadezhda to help me with
Okay.
next slide. Hello, everyone. It is so exciting to me to be a part of this school. Thank you so much to Alina Nechyporenko for invitation to be here. I'm Victoria Alexeyeva. I'm from Kharkiv National Medical University, and now I will try to tell you directly about multidisciplinarity in our work with Alina Nechyporenko. An example of biometric recognition of personality based on spiral computed tomography data. Next slide. The problem of identification of a person occupies a significant place in forensic science. Next. Next. So the aim of our work was to detect features of the paranasal synapse structure which helps in recognition of a person. Next slide. The overall process that allows for personal identification according to the paranasal synapses can be divided into 4 sub-processes. First, it is a spiral computed tomography image acquisition. Next, selection of image parameters to form a reference series. Next, preprocessing and labeling of SCTs. And decision making based on convolutional neural network model. Next. Our study involved 332 male and female patients without any complaints on ET organs. Next slide. Would you please come back to the previous slide? And following parameters were calculated, such as upper facial index, which helps us to determine the human facial type, sinus shape, thickness, length of frontal sinus walls, as well as their density. Next. A new phase in place image preprocessing and labeling of SCTs images. To collect and process SCT data, recognition system has been developed, and you can see in the figure 4 a block of diagram for detection of this system. And the last phase is decision, where the classifier can be used to compare all stored data to receive image and return identity based on measure of similarity or dissimilarity. Next. And we have got results. You can see in the table 1 distribution of our patients according to the upper facial index. Next. And we detected some specialties of the structure of paranasal sinuses, for example, of frontal sinus. In 18 cases, unilateral aplasia of frontal sinus was detected. Some patients had hypoplasia, decreased sizes of frontal sinuses. Some patients had hyperplasia, and sometimes it was so significant as it is shown on the picture, on the figure 7. Next. Then, at the next stage of our study, the structure of folds was detected. We detected the thickness, length, and density of all walls of frontal sinus. Next. And you can see results of our calculation. Next. So we detected that the thickest and densest bones were observed in lactans according to facial index. Female urines are found the thinnest and bones with low density. And we had even a moderate positive correlation between lower and posterior, between the density of lower and posterior walls of frontal sinus. Next. So, in conclusions, I would like to say that new approach for biometric identification based on parameters of perinatal sciences has been proposed. And the structure of human perinatal sinuses is unique, and this fact can be used to detect the person, because some other signs, for example, fingerprints, can be destroyed because of some reasons, and that's why we can also use this method. Thank you.
Thank you, sir. Really unusual. Thank you, sir. Quite unusual approach for biometric identification, because usually people use fingerprints, but this. Could you repeat, please? Maxillary sinus.
Frontal sinus.
Yeah, frontal sinus. How do you think? Is it? What kind of perspectives do you have in terms of implementing this in medical practice very soon, or how long does it take?
And this method can be implemented directly now, from nowadays, because it is easy. It is no difficult to calculate this, and of course it is promising method for all branches of medical science.
Yeah, thank you, Victoria. So
Maybe someone.
hopefully, yeah,
Question?
please. Do you have a question? Yeah.
Yeah. Maybe I didn't understand something, but is it reproducible? Have you studied the same person a few times to see is this trait, the size and shape of this nasal cavities the same, and it doesn't change time to time?
Usually bones, they never change. The structure of bones is stable, that's why we can use this method. Maybe some changes can be present, for example, after some trauma, some fractures of bones, maybe because of this, but it won't be significant, and not all bones will be involved in this process of trauma. Of course, we will have stable walls, and for example, posterior wall, it is the thinnest and the lowest intensity wall, but trauma of this wall is almost impossible because it is located deeper in the skull. That's why it is a promising method, and our method is based on presence of CT examination almost in all people. I have a lot of patients. I work at otolaryngological ENT department of Kharkiv Medical National University. That's why I have patients, and almost all my patients, they have CT examination. That's why if, for example, I have a patient and this patient has this CT, and because of any reasons, we need to detect this patient after his death, for example, and then we need to take a skull, or to take this patient, do CT for this patient, and we had some CT from previous time, and we can find some similarities or dissimilarities, and give result. Is this that patient or some other person?
Yeah, maybe we should add that we use some software for the measurement, and of course, we can repeat this measurement.
Yes, of course. Anytime we can repeat this measurement anytime we need.
And the procedure is reproducible. And today, actually, we'll have one lecture regarding reproducibility and reproducibility crisis, and why we're raising this topic not only for biologists and biochemists, but for computer scientists. Also a question. We'll discuss it today, and maybe also during our week at the bars. So it's really a crucial topic. Thank you for raising this. So now I invite Shevchenko. try it, and it doesn't work. Since we have less participants than expected, I think we can have some discussions. You can prepare a question. Please ask.
Hello. I will tell you briefly about simulation of epidemics and agent-based approach to that. Next slide, please. So I'm associate professor of mathematical modeling and artificial intelligence department in Kharkiv Aviation Institute, and we are making research on simulating the epidemics before it was so trendy as now. Next slide, please. So before we'll talk how to simulate epidemics, let's talk what is epidemic process. So epidemic process is a continuous interaction of 3 points. It's a source of infection, transmission mechanism, and susceptible organism, and they should interact continuously. This is called Gromashevsky triad. Gromashevsky was a famous Ukrainian epidemiologist, and this definition is not only actually for post-Soviet countries, but also for Europe and the US. Next slide, please. The epidemic processes as a class of tasks has different features. That's why we cannot apply standard methods for forecasting, like machine learning and so on. Actually, we can, and we'll have such very good accuracy of forecasting, but the task of simulation of epidemic processes is not just to forecast the future dynamic, because it will say to the doctors nothing. We don't need just a forecast. We need to find out why the dynamics growing and which features impact the most the dynamics of epidemic process. And that's why actually the good accuracy of forecasting is not a good thing, because that means that government and people who are making decisions on control measures doing nothing, and the epidemic process is going on its natural way. Next slide, please. So that's why, and next, maybe, and a bit more. So that's why epidemic process simulation has another method. Maybe you've seen the SIR model, which is simulate like population with different types, like susceptible, infected, and recovered. The population goes from one state to another continuously. And the next slide, please. And it's described by differential equation. And next. Yes. Like that. So why it's not so good idea? Please continue the presentation. Because this is a simple case, but it's a simple model. And next slide, please. And if we are talking about real epidemic processes, for example, current pandemic of COVID-19, please, next slide. We can see something like that, and this is so huge and complicated. And the main disadvantage is that we cannot make changes quickly to that model, and we have to rebuild the model with changing the dynamics. Next slide, please.
Yes, and there are some other disadvantages. That's why we propose to apply agent-based approach to simulate epidemics. Next slide, please. So agent-based approach has following properties. Its activity. Each agent is capable of organizing and implementing an action autonomy. Each agent is independent of the goal. Each agent has a goal and behavior according to that goal and motivation. And rational agents has a knowledge base and they behave in intelligent way. Next slide, please. Another feature and what is actually agent-based simulation is that we have agent as a human with properties, with knowledge base, as I said, with rules of interactions between each other and with interaction with the environment. And that behavior of individual agents makes the behavior of the whole system. So if epidemic process is changing, we just change properties of behavior of agent on individual level and have changes in all model, like in general level. Next slide, please. So it looks like that, like agents interacting with each other. Some of them became ill, after that recover or dead, and so on. Next slide, please. Yes, it looks like that. And when we have a verifiable model with real data, so we have enough accuracy, we can make experiments with that and find out which factors are influencing the epidemic. So we can change some probabilities of a transition between states. We can see how will, for example, wearing masks impact the dynamics, and so on. And I think that's all. Thank you for your attention.
Thank you. Hot topic. Do you have some questions regarding simulation and regarding COVID? And actually, what have been also done except COVID? Did you have some experience earlier with other disease?
If we have 2 minutes, I can tell you.
Yes, we have, because we have only.
Then maybe first slide. Can you open the slide after the last one? After thank you. Yeah, number 14.
It's really fascinating. So I want
14. Yes. So as I said, we have different tasks, and I can tell a bit about our previous model. So this is a model of syphilis simulation. We had a task of identifying factors which are influencing. And here we have frequency of checks is the most influencing factor. And we made it in a Netloga environment. It's not actually very good for using in industry and government, but to find out such factors, it's okay, because we don't need high computational power. Next slide, please. The next task was simulation of diphtheria, and we need to find out which percentage of population we have to vaccinate to eliminate the disease, because it's vaccination control disease like measles and so on. And we had 93%, but it's only for children. If we'll vaccinate 93% of children in given territory, we could ignore vaccination of adults and will eliminate the epidemics. Next slide, please. So also we've made some long-term forecasts, and actually it's not a typical task for simulation epidemics because we need to make decisions very quick to eliminate the epidemics. But if we are talking about such diseases like HIV, we need to make global trends to plan economical issues for government, because a lot of people are living continuously with HIV and it's impacts the economics also. Next slide, please. Forecasting, I said, it was like hepatitis B. Next slide. Yeah, and also another task is building epidemic thresholds, and when you are forecasting and see when when your forecasted morbidity will be higher than epidemic threshold, that's a signal for some measures implementing. This model is was implemented in Kharkiv laboratory center, which called sanitary and epidemical station at that time, and it works by now. And like schools in Kharkiv were closed 3 times, I think, because of results of our model. I think that's all.
It looks like you have many partners on medical side. And is it difficult for you to collaborate? And how you're dealing with some issues? And actually, one of the questions, where to get the data? It's open data? I don't think so. Open data set or
it's
big
different
data?
with COVID. We have a lot of data, open access.
From whom? From medical partners or?
From open access data we have from such institutions like Johns Hopkins University, but not actually personalized because it's anonymized but like with more features. Data with more features we have from Center for Public Health of Ministry of Health of Ukraine.
So my question was really related to Ukrainian data. Do you have such a possibility to get data here in Ukraine, not only in Stanford?
Yes, actually in Ukraine it's easier because, for example, when I was in conference in the US and we were talking about simulations, they said that it's impossible in the US because they have in different states different data, not all data digitalized. In Ukraine we have all data about incidents, about morbidity, new cases, deaths, digitalized, not only with COVID, but with different diseases.
All the data should be analyzed.
Yes,
really
yes.
Important to follow these regulations.
Yes.
Today, we'll talk about some fair principles, about accessibility of data, and so on. So, yeah, please.
Which software you usually use for integration of this?
It depends on task. Actually,
For example, this nice thing, this green balls.
it was actually NetLogger because it's a good environment to start with agent-based simulation. It's very not easy, but intuitive. You can try it, just read some manuals and start with that easily. And after that, switch to some programming languages to increase the computational complexity and speed.
So it's an easy thing to use just for showing something.
Yeah, and actually it works. You can apply that and you can have scientific results from that. But if we are going to use some models in like industry or in government, we need to have not a big data, but a lot of data, and we need to process it simultaneously. And with the NetLogger doesn't have such opportunities to process a lot of data continuously.
Thank you. Does anybody have more questions? So,
Thank you.
Now I can invite you, Alina Nechyporenko. Please, your turn.
Hi, my name is Nela. I'm a postgraduate student of the Department of System Engineering. I would like to tell you about the work that was done under the guide of my scientific supervisor, Doctor of Technical Scientist, Professor Perova Irina. The topic of my work is Madalina neural network. Madalina is adaptive linear element for medical data mining. Its learning algorithm can be used for situations when information is received for processing online. This neural network is trained on medical data and shows a high level of data distribution over a large number of indicators. On this slide, you can see the neural network Madalina. That neural network has a vector input features that are fed to the input of the system. Then the features are fed to the synaptic weights, the value of which of the first step and the set randomly. After the value of in the input vector and synaptic weights are multiplied, they are fed to the adder, and then the result goes to the analog output. For the results to be more accurate, this neural network should be set up as well as possible their synaptic weights. For this, after receiving the vector of output features, its value is compared with the reference known signal and an error signal is researched. Based on the error signals, the synaptic weights become more accurate by using the learning algorithm. All these steps are repeated until the error signal is not minimal. The vector of the diagnostic is necessary for the convenience of the doctor diagnostic. This. The main advantage The main advantage of this neural network is that the product for certain synaptic weights has recurrently and gradiently. And the disadvantage of this network is outfitting. Thank you for attention.
Actually, could you tell a bit more about the name, Madalina? What does it mean?
Madalina is a linear network who built with two Adeline. It's a simple network than Madeleine. Two Adeline is Madeleine.
So, is it clear for everybody? Okay. What is linear network? You said, what is Madalina? Is it linear?
Adaptive linear network.
Yeah, what is it?
Who was linear I can see linear vector, like linear vector of input features, who set on the output input.
Okay. Then today we're already discussing some issues, how to overcome the overfitting. Maybe you can tell something about this briefly, or no? Or we postpone the discussion. Let's do it.
Talk about my fitting.
you just already talked about overfitting. There's some disadvantages of overfitting, and my question was how to overcome overfitting, how to deal with this kind of problem.
I used medical data. It's fitting patient campaigns, diagnostic indicators, clinical and biochemical blood tests.
And regarding technical parameters, some not about the data, some parameters of network. Oh, this is clear, yeah? Okay, thank you.
Thank you.
Then,
This is Alexander Nechyporenko.
Hello everyone, my name is Alexander Nechyporenko. I'm a PhD student from the Institute for Radiophysics and Electronics, and today I would like to tell a little bit about the terahertz radiation and its application. So what is the terahertz radiation? It's electromagnetic radiation with frequencies from 0.1 up to 10 terahertz. This frequency range is called the terahertz gap due to the lack of the radiation sources. At the same time, the terahertz radiation has a very attractive and promising application in biology, medicine, and other fields. Terahertz waves produce non-ionizing effect compared to the X-ray. So in our case, we used vacuum electron devices to obtain the radiation with reasonable power levels. The experimental setup for the investigation was as reflected as an transmitted radiation you can see at the slide. The scheme was extended to measure the phase shift of the signal that allows to obtain in-depth data for further analysis. The first experiment about the image reconstruction was made for the 3.5-inch floppy drive. At the left side, you can see the reflected radiation, and the right side, the transmitted. But I need to say that this experiment was carried out manually. I mean that we moved the sample by our own hands. That's influence on the resolution. Of course, in our future plan is to automate this process with step models, for example, and we already made this. The using of the terahertz radiation for the cancer detection is not new, but as I said earlier, there is a lack of the radiation sources with reasonable parameters. So the main specific of this technique is the detection of the water content in the tissue. It's already known that the tumor and the normal tissue has a different water content. So the terahertz radiation has a very strong attenuation in water molecules. Thus way, the even small change can be detected. So we in our institute have people who deals with computer tomographic image reconstruction, and we asked him what we have to do with this picture, and he suggested to use the convolutional neural network because it's one of the popular model for image processing. And as you can see, the convolutional layer is a key component of this network. Its purpose is to detect the presence of some features of the object, like an edges, circles, corners, and etc. And for example, at the slide you can see the green image at the left corner with the kernel filter on it. Each cell of this filter has his own weight values, market rate. So applying them, we obtain the convolved feature, which filled with the values by sliding this filter through the all pixels of the image. After that, we apply the rectifier linear unit and pooling operation. It can be max pooling or average pooling. The pooling layer is often placed between the two convolutional layers. The pooling operation is consist in reducing the size of the image while conserving the important features of the image. And the fully connected layer is always the last layer in such type of neural networks. It's obtained the massive of data and computate the probability of each classification in the output by multiplying the input vector each element with the weight values, make the sum and activate and use the activation function. And after some during the training phase, the weight values becomes more determined, and the neural network can classify the images. Thanks for your attention.
This question, I actually have one, not only one. The first one was resolution. How are you going to improve the image resolution?
Improve what?
Image resolution.
Of course, the image resolution depends on the frequencies because it's a length wave. In our case, we use the tubes with a floppy drive for 30 gigahertz, but it's the problem that we haven't each one tubes already. We need to produce them by ourselves in our institute, and this process takes a very long time, and a lot of people are involved in this. So, but we have tubes for different ranges, like 130, 300 gigahertz.
So it's produced by your institution?
Yes, it's not
standardized or
standardized? No, I think no. It was standardized in Soviet Union, but we in our institute with my supervisor we improve something, but of course it's just in our papers, not standardized.
Thank you. And please ask.
Thank you so much for your research. And for doctors, the most important aim for doctors is to tell about malignancy of tumor, because melanoma is very malignant and very dangerous. Maybe you had some math and some others which help to compare benign and malignant tumor to tell about malignancy. Maybe my question is so medical, I'm sorry for this. But we need to compare all this benign and malignant tumors. Maybe you have some research about benign tumors, and maybe you know some differences between it. Thank you.
Thank you for your question. As I understand, we have the frequency modulated continuous wave radar method to investigate the depth images, depth data. So maybe it will be helpful for this target.
But you personally didn't do such research?
It's one of the chapter of my thesis.
Okay. And please. More questions? Doesn't seem to be a case, but I have some question regarding neural network architecture. What kind of architecture did you use?
We are very newbie, I can say, in this thematic. We more electronics,
Okay, you just
vacuum
presented
devices. So
evolution neural network. I want to ask. Okay, yeah.
it was the first task when we achieved from our friend who involved in this, and we just started as this program.
I just wondered maybe it was Alex did or something.
Did you mean typical?
Yeah, I mean some particular.
Yes, we are studying this question. Maybe choose something
Okay, so
already.
it's only.
It's
Yeah, it will be around.
just on the start
Okay, yeah,
stage.
Okay, then thank you.
Thank you.
We have, I think, 20 minutes left. I think 15 minutes. We can just discuss some issues.
Comment.
Yeah, please.
Okay. I'm pretty sure that you are all good scientists or will become good scientists. We have divided this in two groups. We call one group the AI nerds, which are at the same time more or less the nano dummies, and the other way around. Yeah, so one group is from one field and the other group from the other field. Maybe there's people who do both, no doubt. And the task was to explain your subject to the other group, assuming that those people have little knowledge of. I'm not sure whether you were successful with this. Please ask in the lunch break those people which are from the other group how well they understood the subjects. And then you get an idea how well you have done the job. Your job in the future is, of course, to do complex matters, to do research. But your second job is to make it simple, to make it understandable. And that will make you successful in the end. If you can break it down to simple things and at the same time motivate people to listen to you. It's very simple to present something very complex. And you should keep in mind, and this is now the message for the second group, you will not change anything in your presentations because time is too short, of course. Yeah? But you can change a little bit in the way how you present. I give you two examples. We had these images of the cats. I will start a bit different. You have a message, the message is your subject, and then you subdivide it into sub-messages. Each slide is a message. With each slide, you address your auditory and you want to transfer a little piece of knowledge. And that means it should become very clear what you mean, what you're talking about with this slide you're presenting, because you're not presenting 25 slides, you're presenting 6 slides or so here. And either you have a very clear, simple message, which you do not need to explain a lot. So let's say a cat, and then you turn the image that way. Very nice example. You don't need to say a lot. It is a very nice example for a very simple message. Make it a new image just by turning. This is the take-home message of this slide. And then we saw a lot of slides with diagrams, figures, let's say a heat map or so. And now imagine somebody has not seen your image, which is true for the bigger part of the auditory. You have seen it many times because you created the image, maybe. But you have to explain it. And the most simple explanation, let's say it's a diagram with 2 axes, The most simple explanation, if you only have 20 seconds to show something, is first you say, we see on that axis, let's say the years or whatever, time, and on that axis we see whatever. And the message of this slide is to explain to you the spread of whatever. So please keep this a little bit in mind. So the first group asks the second group, what did you understand? And the second group tries a little bit to follow what I said for their turn. Thank you.
Thank you, Professor, for your contribution. This is why really talking it's challenging to collaborate and understand each other. Yeah, and now I want to give a few words to Ivan Izonin. He tells a bit about like some announcement.
Could you help
Nadia.
Dear colleagues, most of all working on medicine, nano and AI. In Lviv we have a conference. In this year it will be, in this year it will be the fourth conference that indexes by Scopus, Web of Science and DBLP. It's the first Ukrainian conference that has rank C according to the core list. It's very important in Europe. It is free of cost for you, and for students it will be interesting if you have some novelty in your research, you can present it. It will be good for your master thesis or bachelor thesis. For young scientists, it will be interesting because it's indexed by Scopus and Web of Science, and also it is free of charge. This year, this conference will be in our partners in Spain, but using Zoom online conference. The deadline is for October, but we can provide some prolongation till 20 October, if you are interested. Next, please. You can find a topic of the conference on the slide, if you are interested. If someone want to write a paper, please ask me and I explain you more detail. Next, registration is free of charge. Next, please. And after the conference, we have a lot of special issues in good journals where you can publish your extended version of your research. But in this case, you should have a strong computer science novelty in your paper and some medicine task. Or in the case of nano research, you also can write a paper. Next one, please. One of them, it's a mathematical biosciences and engineering journal. It has an impact factor 2.08. It's a good journal, but it is not free of charge. Next, please. If you want to publish your paper in a good journal, in good European journal, you can choose this one. We also have a special issue on this journal. It's a second quarter, and you can publish your research there. Yeah, and the last one, please. And for strong scientists, in this case only for strong scientists, because it's very high impact journal, impact factor 4.5 as I know. We have a special issue there. It's the first quarter. Journal is the first quarter, but in this case we should have a very strong computer science, not task novelty in computer science, and strong medical task. Not just take some data sets from with mentioned repository or something else, but we should do strong components, and you can publish your paper there. Thank you for your attention. If you have some questions.